Howdy. Today I'll be answering the question, how are derivatives and integrals helpful in the real world? So let's take a look at some real world examples. First, we will be taking a look at the Six Flags roller coaster, the Batman the Ride. Secondly, the GDP in the Great Depression time. Lastly, the actual fuel consumption for vehicles. Determining roller coaster integrity. The overall goal of coaster integrity of any coaster is to determine if it is safe for passengers, to prevent injury or worse, blackouts, and to calculate if the cart will actually make it around the track. Taking a look at the vertical position versus time graph of the Batman, this shows where the rider in terms of t seconds, and more notably, where the sudden changes are in height differences are. Now taking a look at the derivative or velocity versus time graph, we can see how fast the coaster is moving up or down. This helps determine the speed after drops, especially those in very big initial drops that most coasters have for momentum, and also predicts if the cart itself will make it through the coaster or not. Taking a look at the second derivative, which I would argue is the most important graph, acceleration versus time graph. This shows what the riders experience on the ride. Large positive on this graph shows people being pushed into their seat, and large negative shows the rider feeling weightless here. Overall, this graph determines the g-force by the equation g-force equals acceleration divided by gravity. More notably, overall, it is dangerous for riders to be above 4 Gs, so the coaster designers have to be mindful of this safety precaution when designing coasters. Now let's talk about the Great Depression in real GDP, which will show the change in GDP over the years, along with determining the real GDP recovery and positive growth. Taking a look at the Great Depression real GDP, that was caused by bank crashes and factories overproducing their products, we can see a massive drop in the real GDP from 1929 to 1932, and then a massive recovery from 1933 to 1937, which was saved by the New Deal. Now looking at the derivative of this, we can see where the GDP growth rate starts to recover and becomes positive, and then eventually evens out, that when large increase from 1931 to 1934, it evens out and stabilizes as real GDP should. For the last example, let's take a look at fuel consumptions per distance change for two vehicles, which helps buyers compare vehicle models from different years. For example, let's take the Nissan Vereza and the Ford F-150. These two graphs show the difference of models and fuel consumptions usage over the years, and as you can see, both increase over the years. Taking the integrals of both graphs, shown here, we can get a clear picture of the comparison. These show the overall these show the overall positive improvements in the distance per gallon over the years. Then also at the same time compare by year if one or the other is better in fuel efficiency. And this is a good way for vehicle owners to decide what vehicle to buy based on what it would cost them for gas. This is our works cited. And thank you for your time, and I really hope you have a great rest of your day.